Welcome back, ladies and gentlemen of the Integrated 2 team. We are looking at Quadratic Enrichment number 2. So, it was good to see you guys today. And so I figured I'd just make a video for those who missed the class this afternoon. So from here, it'll be pretty fast. You know, a bunch of factoring, that's all we're really looking at. Looks like I've got two b plus 5s in common here. I'm going to go and factor out that b plus 5. And that leaves me with a b minus 3 on the inside. That's as far as we can go. Pretty basic factoring stuff going on with this problem here. Number 2, the coefficient in front of the y squared is positive and 1. So I'm going to go ahead and just kind of go for it. And so, in case you guys can hear, it's raining pretty hard. So it's probably raining really hard in your neck of the woods too. So that's a little distracting right now, but that's okay. Y minus 7 and y minus 2, you know, because 2 times 7 would get you the positive 14, 7 minus 2, negative 7 minus 2 would get you the negative 9. No worries, we're all good here. This guy is pretty basic also, so k and k, looks like I'm going to go with a plus 5 and a minus 3, but because there's an m following on each of the second and third terms, each one gets an m. Number 4 is some zero product property going on here, so I'm just going to go for it first. So I've got 3d and d. The signs are going to be minus plus, which means on the inside it's going to be minus minus. I'm going to go and set that equal to 0. And then two numbers that multiply to 20, that's all I really need. So I'll go and just throw down a 5 right here and a 4 right here. I'm going to go and check to make sure that that works. Negative 12, negative 5. I believe that nets me to negative 17, so I think I'm in a good position. So 3d minus 5 is equal to 0. D minus 4 is equal to 0. So d equals 5/3, d equals 4, and we're ready to rock and roll. Now if you wanted to do this one with a diamond, there's no harm in that. Let's go ahead and take a look at how that would look as a diamond. In the diamond, the top number would be a 60. The bottom number would be negative 17. It is really coming down hard right now. Cool. The two numbers that I'm looking for that are going to satisfy both multiply to positive 60 and negative 17 will be negative 12 and negative 5. What that gets me is it gets me 3d squared minus 12d minus 5d plus 20. And that equals 0. And now from here I can factor out a 3d, and I'm going to get d minus 4 minus 5, and then d minus 4 equals 0. And then if I factor out a d minus 4, I will end up with a 3d minus 5 equaling 0, and now we're back to this step here. So there is your diamond version of that problem. Number 5, pretty simple, difference of squares. So 7x minus 10y, and then 7x plus 10y, and that's all you need to do. Number 6, factoring by grouping. How do I know? It's because it's a 4-part polynomial. 4 pieces means I'm going to group the front piece and the second piece. From the front, x squared pops out, giving me x plus 3. From the rear piece, 7 pops out with an x plus 3. Pop out an x plus 3, and you get an x squared plus 7. Alright, let me pause for a second. I'll be back with the next 6. And we are back for round 2. So I apologize, I am going to move a little bit faster in this video because we went over this today, this afternoon. So hopefully, if you need to see it again, just rewind or whatnot. Number 7, factoring by grouping. We got a 4-part polynomial again. So I'm going to factor out, looks like a 2a squared. That gives me, looks like 4a minus 1. And then I'm going to factor out, looks like a 3. And then I've got 4a minus 1 equaling 0. I can factor out a 4a minus 1. That gives me 2a squared plus 3 equaling 0. Then I've got 4a minus 1 equaling 0. And then 2a squared plus 3 equaling 0. a equals 1/4 here. A is equal to no solution here. And the reason why it's no solution is because you end up getting 2a squared equals -3, and then a squared equaling -3 halves. And if you square root both sides, the square root of a negative number is not possible. At least not in real numbers, but we will learn imaginary numbers at some point, and when we do, we will be able to do this this problem here. But for now, just go and put no solution for this guy. The answer is really only a equals 1/4. Number 8, perfect square trinomial, and my hunch is because I see a perfect square here and a perfect square here. The last term is positive, so I think we're in good shape. So 5x plus 4. 5x plus 4. Does it work? I think it does. 20 plus 20 is 40. So you could also write this as 5x plus 4 squared. You don't really have to, but it's good to see them both ways because at some point we will learn how to do completing the square, which will require us to convert this into that. So it's always good to see it. We talked about this afternoon. Please, GCF, be a good Street Fighter player. And there we go. So 2. And then looks like I'm going to go for x minus 9 and x plus 2. Very cool. Moving on to number 10. I can factor out, looks like a negative x to the 4th. Now, generally speaking, I would say about 97% of these problems, when the leading coefficient is negative, you factor out a negative version of it. Sometimes it helps to keep it on the inside, but you'll see that in later math classes. It's not mission critical right now. X squared minus 9x, actually, sorry, that should become a plus 9x, and then minus 90 equals 0. And again, the sign's changed because I factor out a negative version. So from here, negative x to the 4th, and these guys are going to factor, it looks like x plus 15 and x minus 6 is going to be our combo there. And so from here, negative x to the 4th equals 0, x plus 15 equals 0, and x minus 6 equals 0. So x equals 0, negative 15, and 6. All right, we're almost there. This one's pretty simple. Perfect square here, perfect square here. The last term is positive. I'm suspecting x minus 11. X minus 11, does it work? Negative 11 becomes negative 22. So again, you can, if you want to, you can make that one big deal squared like that. And then number 12. Believe it or not, number 12 is exactly like number 11. You can call him x minus 1/5 and x minus 1/5. Does it work? I get a negative 1/5 here and a negative 1/5 here, giving me negative 2/5 if I combined them out. And then these guys would multiply to become positive 1 over 25. I think this is it. So x minus 1/5 all squared. And there we go. All right, short video, but it was good to see you guys today, this afternoon, and we will be in touch for the next video and for the next meeting. Please make sure you take care of your health, stay indoors, and we will talk soon. See you later.